Hi everyone, today we're going to continue our conversation about how to factor. Last time we looked at factoring just using the greatest common factor, so let's just review that really quick. So here we have a polynomial, and so we're going to look to see what do both of those two terms have in common. Well, we can see based on the coefficients, the 2 and 4, they both have a 2 in common as factors. They also both have an x. This one happens to have two x's, and this one has one x. So we can say that they both have at least one x in common. So if you remember from last time, to factor out that greatest common factor, we can divide all the terms by that greatest common factor, and what we have left over becomes our answer. So here we have our greatest common factor, and then we're going to multiply it by whatever's left from this division. So 2x squared divided by 2x is going to give me x. 4x divided by 2 is going to give me 2. So now we're left with 2x times x minus 2. So that was just a quick recap of how to factor using the greatest common factor. We're going to utilize this idea some more as we work through our factoring of trinomials and polynomials with 4 more terms. All right, so to factor a trinomial, something that is 3 terms, one of the things that we also have to think about is usually when we're factoring a trinomial, using this method, it's also what we call a quadratic. That means that the biggest degree is 2. So the very first thing we should always do is factor out a GCF, if there is one. At least check for a GCF. Then I'm going to teach you how to factor using the box method. If you really don't get the box method, then I can teach you another way, but the box method does tend to be the easiest way. So here we go. The box method. The first thing we do is we draw a box and then we fill in the first and last term. And as we go through, first I'm just going to give you all the steps, then we're going to put them to use. Then we're going to multiply a and c and make a factor table. When we get to an actual example, I'll show you what I mean by a and c. Next, we're going to find 2 factors that add up to b. So I'll show you what b means. Then we're going to fill in the remaining squares with the factors that we found from this factor table here. Then we're going to find the greatest common factor for each row and column. And then we're going to write out our 2 binomials. It looks like a lot of steps, but I'm going to tell you right now that the first 3 steps are actually pretty quick and easy. Right? Really, the first 2 steps are really fast and easy. All right, so one quick little note to this is if you have 4 terms, because sometimes you will be given a polynomial that has 4 terms, we don't have to do these steps 1, 2, and 3. Okay? We just jump straight to 4, and we fill in all 4 boxes with those 4 terms. And I'll show you a couple examples of those. But first we're going to start with this trinomial here. So the first thing we're going to do is we're going to make our box. So there's my box. Okay. Now, when we're multiplying with the box method, we would take those 2 binomials, put them on the outside, and then multiply to fill in the inside. Well, now we're going to start with the inside and work our way to the outside to get those binomials. All right, now if we go back up to our steps, it says to multiply a and c. Well, and then we talk about adding up to b. What on earth does all of that mean? Well, every trinomial is going to be labeled this way. The first term is your a, the second term is your b, the third term is your c. So the first thing we're going to do is we're going to take that a term and that c term, just the numbers, include signs with it. So in this case, my a times c is going to be the 2 times the negative 35. And that gives me negative 70. So now I've done my first 2 steps. I drew my box, and then I multiplied my a times my c. All right, our next step is to find 2 factors that add up to b. Well, in this case, my b is negative 9x. So I'm going to make a t-table. And this is how I make mine. And my little triangle here that I put has an actual purpose. You don't have to put it, but I have an actual purpose for it. So I want my factors that I come up with have to add up to my b term. In this case, my b term is negative 9. So we have negative 9. All right, now here's why I put this triangle. It's going to help me with my signs. Since this b term is negative, that means that every number I put in this column when I'm listing out factors of negative 70 has to be negative. All right, so now this is where my triangle comes into play. I'm going to use that to help me figure out what my sign should be over on this side. So a negative times a negative has to equal a positive. And I can do that using any two signs, and it'll always work. I could take the negative times a positive makes a negative. I can work backwards. A negative times a positive makes a negative. Or I could start here. A positive times a negative makes a negative. So I'm constantly hitting those 3 points. All right, now that I know what my signs should be, now I can just think about factors of 70. And when we come into class next time, I'm going to show you how you can actually get this table in your calculator, and you don't have to come up with these factors on your own. The numbers in my left column will always be my smaller numbers. The number in the right column will always be my bigger column, my bigger numbers. So factors of 70. I've got 1 times 70, or in this case, since going based on my signs, a positive 1 times a negative 70. It's even, so I can divide by 2. So 2 times negative 35, 5 times negative 14, and 7 times negative 10. So those are all my factor pairs that will lead me to negative 70. Well, I need to find the pair in here that adds up to that negative 9. So in this case, it's this pair right here, the 5 and the negative 14. All right, so now we're going to take our values and we're going to fill in our table. All right, so my A is going to go here. My C is going to go here. So this will always be my A term. This will always be my C term. These two numbers that we found over here, these two factors, are what's going to go into these two remaining boxes. All right, so my A term was 2x squared. So I'm going to type that in, 2x squared. My C term is going to go here, and that was a negative 35. All right, now I'm going to fill in these two, and that's going to come from these two here that I just circled. So it was the two numbers that multiplied to my A times C value and added to my B value. All right, so I got the 5 and the negative 14. When I do this, I have to include an x with them. So it doesn't matter which one I put where. I'm just going to put the negative 14 here, and I'm going to put my 5 here. Now, don't forget, we have to put the x with them. That's one piece I always kind of forget to do. So we do need that x. Okay, now that we filled in our box, so again, this was my A, this was my C, and then these two were the ones that I pulled from right here. These again are the two numbers that multiplied together to make my C term and added up to make my B term. All right, now, filling in the box isn't so bad. Now we need to deal with that idea of a greatest common factor. So, doesn't matter where we start. I'm going to start with these two terms here. So I want to know what is the greatest common factor of 2x squared and negative 14x. What do they both have in common? Okay. So they're both even, so I know I can divide them both by at least a 2. Since my smaller number is 2, then we would say 2. They both also have an x, or at least one x. So we can say that the greatest common factor is going to be 2x. All right, now let's take a look at these two. So I want to figure out what's the greatest common factor between 5x and negative 35. So in this case, this is the only term that has an x. This one doesn't. So x cannot be part of my greatest common factor. So I just look at the numbers, the 5 and the negative 35. So the greatest common factor is 5. All right. Now let's go this way with our columns. So my greatest common factor between 2x squared and 5x is just an x. And my greatest common factor between negative 14x and negative 35 is a negative 7. So here's a little hint. If the whatever number is closest to the top of the box or to the left of the box, okay, whatever that sign is, it's going to map, the factor is going to have the same sign. So because this was negative, this is negative. This is positive, so this is positive. This is positive, so this is positive. This was positive, so this is positive. Okay? The sign of this guy doesn't really matter much when we're trying to figure these out. So now, when we want to actually go to write our binomial, we are taking these two things across the top, forms one binomial. So I have an x minus 7, and then these two here form my other binomial, my 2x plus 5. So there's my final answer. I factored it. All right, let's take a look at some more examples. You do have a try on your own here. First thing you're going to need to do on this one is factor out a greatest common factor. So before you do this one, we're going to take a look at a couple more examples where you're going to see that happening first. All right, so now let's come down here and take a look at example 2. This one already has 4 factors, or 4 terms. So because it already has all 4 terms, those 4 terms that I need to fill in my box, I don't have to do my a times c and make that table to the side. I don't have to do that here because I already have all 4 terms. All right, so in my first box, I'm going to put that first term, my 10x, and I'm going to raise that to, in this case, the third power. In this box, I'm going to do my 6x, and I'm going to raise that to the second power. In this box, I'm going to put my 5x, and in this box, I'm going to put my 3. So in the grand scheme of things, the only 2 boxes that really matter are the top left and the bottom right. Those should always be your very first term and your very last term. The 2 middle terms can go here. Doesn't matter which one goes where. All right, so now let's go ahead and take a look at greatest common factors. So if I look at these 2 here, the greatest common factors between 10 and 6 would be 2. And then this one has 3 x's, this one has 2 x's. So they have a total of 2 x's in common. So we can say 2x squared. This one here has nothing in common. So when the only thing that I can divide both of them by is a 1. So I can't divide 5 and 3 by any other number, and neither of them, they don't both have an x or a variable. So 1 is the only thing that can divide into both of those. So we pull out that 1. All right, so now that was looking at those and those. So now let's look at the vertical, at the columns. So when I want to look at these two, the greatest common factor between 10x cubed and 5x would be 5x. I can divide them both by 5, and then they each have at least one x. And then I can look at this one, a 6 and a 3. They can both be divided by 3. This is the only one that has any x's, so they don't have any x's in common. So just a 3. So my answer is going to be taking those 2 and these 2. So I get my 5x plus 3 and my 2x squared plus 1. Here's a try on your own with 4 terms, so you're going to set up just like we did here. But before you do that, let's take a look at another example. So this one here, I actually already have the first 2 boxes filled in. So I drew my box, I filled in my A term, and I filled in my C term. We still need to find these 2. So in this case, when we go to do our a times c, my a, my coefficient, is that invisible 1. So that 1 times 5 gives me a 5. When I go to set up that t-table, I need to find factors of 5 that can add up to -7. Well, the only way I can multiply numbers together to make 5 would be 1 and 5. Or, since it's positive, it could be -1 and -5. So we could also use those. So I could say -1 and -5. Those are the only two ways I can multiply numbers to give me a positive 5. So if I were to check, do either of these add up to -7? Well, 1 plus 5 adds up to 6. -1 plus -5 adds up to -6. Neither of them add up to -7. So there are actually no factors of 5 that add up to -7. So there's no factors that will add up to b. When this happens, we call this prime. So this is a prime trinomial or a prime quadratic. So what does that mean? Okay. Well, prime polynomials are polynomials, is a polynomial that does not have a greatest common factor and cannot be factored using the box method. So a quick little note, when factoring, our final factors should all end up being prime. All right, so now we're going to take a look at these two examples here. And the first one is a special case. In all honesty, I don't know why those parentheses are around it. They really shouldn't be. So you can just kind of scratch out those parentheses or just ignore those. So we have x squared minus 9. We call this a difference of squares. Difference, subtraction. The squares means that x squared is a perfect square and 9 is a perfect square. We can follow a very specific pattern for this one. Instead of having to go through that whole box method, we can use a specific pattern here. Okay? If you really want to keep using that box method instead of just learning some of these patterns, then I can show you how to use the box method using this. It's definitely doable, but sometimes recognizing these patterns actually makes life a little bit easier and a little quicker for you. All right, so a difference of squares. Your final answer is going to be written out something along the lines of this. I'm going to take that a squared value and that b squared value. Actually, that should have been c. Oh, that's fine. For this purpose, it'll be okay. And I take the square roots of both. So it's going to be in this pattern. My a squared, square root of the first term, plus the square root of the second term, times the square root of the first term minus the square root of the second term. So first term was x squared, so this, and the second term was 9. So the square root of x squared would be 8, the square root of 9 would be 3. So square root of x squared is x, the square root of 9 is 3. So if I follow this pattern, I will have x plus 3 times x minus 3. And that is the final factored form of this polynomial. All right, so we're going to utilize this idea here to help us over here. So here I have another polynomial with 4 terms. That means I don't have to go through that whole t-table on this one. So I'm going to just open up my box, and I've already gone ahead and filled in my 4 terms. Before I do that, actually, hold on, I'm going to cover that back up for a second. We forgot to do something. Look at each of these and determine if there's a greatest common factor. Okay? So they're all even, which means I can divide by at least 2. I'm going to double check to see if there's anything bigger. Since my smallest coefficient is 2, then I can't go any bigger than 2. So I have a greatest common factor of 2. I don't know why that's not showing up, so let's just put that in there. So I will, oh, there it is. All right, a greatest common factor of 2. Well, now it disappeared on me again. All right, so there we go. All right, so now we're going to divide each of these by 2. And when we do, this is what we end up with. So 2x cubed divided by 2 is x cubed. 4x squared divided by 2, whoops, I don't want that in there just yet, is 2x squared. Negative 18x divided by 2 gives me negative 9x. Negative 36 divided by 2 gives me negative 18. All right, now that we've done that, now we can go ahead and start our greatest common factor process. So I'm going to start with these guys here. This time I'm going to do the columns first. Doesn't really matter which one we do first. All right, so what do these two have in common? Well, this only has a coefficient of 1, but they do both have at least one x. Of course, it's not going to work now. There we go. All right, these two over here are both even, so they can both be divided by 2. Only this one has at least one x, this one doesn't, so we can only bring out the 2. I don't know why it's being so difficult. There we go. All right, now we can factor this way. So when we do, we get, this only has a coefficient of 1, but they do both have at least, in this case, 2 x's. So I can factor out it's in there somewhere. I think I'm just going to type this one in. It's not what I wanted. And there we go. The x squared. And it's not going to stay there for some reason. Don't know why this is being so difficult today. There we go. So I can factor out an x squared out of both of those, and then when I come down here, I can factor out, remember this is negative, which means this is going to be negative. So I can factor out a negative 9 out of both of those. I forgot to draw that little box in. All right, so now we've pulled out all of our greatest common factors, and we can set up those two binomials. So now I've got that x and a positive 2, so x plus 2, and I've got that x squared and that minus 9. So now, got that. Now, don't forget about that greatest common factor that we pulled out at the very, very beginning, because that is going to be part of my answer. Okay? So that becomes part of my answer. Sorry about this, guys. I'm not sure why it's acting up so weird. So that becomes part of my answer. And then I can circle my entire answer when I'm done. Alright, so using that box method, we took those 4 terms, and I noticed that since they were all even, I could divide them all by 2. That was the greatest common factor in this case, so I did that first, put in those resulting values after I divided each term by 2, put in those resulting factors. I was able to pull out the greatest common factor for each row and each column. And once I did that, those greatest common factors turned into this. Okay? Oh, but I'm not finished yet. We're not finished yet. I forgot. Okay. Now, this here, if we recognize it from over here, is a difference of 2 perfect squares. So now I can take this here and I can factor that out. So remember we said that x squared minus 9 can then be factored down to x plus 3 and x minus 3. So now we're going to bring that in. Let me get rid of this. Okay. So now we're going to bring that in. And then that greatest common factor, again, has to come down and be in front. So now we have our final answer. So we had to do a lot of steps here. First, I found the greatest common factor, that 2. That becomes part of my answer. Okay. Then I divided every term by 2 and put those values in here after dividing. I then found their greatest common factors of each row and each column. That gave me these 2 factors here. Then I noticed that this one here was a difference of 2 squares, so I could follow my quick pattern and factor that one out to the x plus 3, x minus 3. So now I've got all of my factors listed out, all of my prime factors, the 2, the x plus 2, the x plus 3, and the x minus 3. So this one here would be my final answer. Okay, so I want you to go ahead and do the try on your own. The factoring piece is a lot, and we're going to spend some time on it together in class as well before I let you do anything on your own. Okay, so we will do some try on your own, or we'll do some practice together in class before I have you go and do anything on your own. All right? So I will see you next class. Please make sure you do at least attempt those try on your owns before coming to class. I'll see you then.